Hey guys, welcome back to Rocket Gyan, my fellow space tubers. And whoa. Today we are here to witness a launch which is going to Jupiter. And yeah, that's right. We are sending something to a Jupiter, not because of its um, Jupiter's gravity assist, but because to study the Jupiter. So after this launch there will be three missions to the Jupiter which will be studying the Jupiter system simultaneously. If you can name them three, then it will be good, because I do know them. So it's a fun little thing for you guys. So just write it in the comments, in the chat, the three missions which will be there in the Jupiter after this one launches. Okay, let's get back to the JUICE mission. So the JUICE, Jupiter Icy Moon Explorer. Well, they come up with a very interesting names, I should say that. And JUICE mission today, as the name suggests, is going to the Jupiter and is going to study the icy moons of the Jupiter. So what are the icy moons? The icy moons, there are three of them: the Ganymede, the Callisto, and one more was there. I am forgetting the name. It won't be studying the Io this time. That's a volcanic one. Yeah, Europa. How can I forget about it? Yes, Europa. So we are, that's the thing. So talking about this mission, guys, let's have a look at it finally. So before that, welcome to the stream, everyone. Hi, Angel. Hi, Daniel. How are you? Hi, Lol Manzi. Jello, yes. Let's see what this juice mission is all about now, and let's get into it. Okay, so the launch date is 14th of April. It was supposed to launch yesterday, but it did not because of the weather issues. But this mission is actually uh, it's an mission to study interplanetary spacecraft. JUICE is nothing but an interplanetary spacecraft to study the Jupiter system. The three primary objective of this mission would be to study the Jupiter's icy moon, to explore the complex environment of Jupiter, and to look at the overall Jupiter system as an archetype for what gas giants are like across the entire universe. So, guys, as you know, Jupiter is a big gas giant. Herein we can see that, and it has like so many moons, around 60 plus moons. It has. So it's kind of can be studied and looked at as a mini solar system, right? So if we study the Jupiter and the moons associated with it, then we can have a whole look at the bigger picture, which is the solar system, because it's kind of behaves like a solar system. So consider Jupiter as a star, and then all those moons as the planets revolving around it. So the formation of it and how different um, how the solar system actually was formed, we will be better able to understand that. So talking about one more interesting fact about Jupiter is, Jupiter is kind of considered a failed star. It was supposed to be a star, but then the sun overwhelmed it, and then sun became the star, and Jupiter was to be made a gas giant. And so why am I saying this? Because Jupiter is the only planet in the solar system in which the barycenter, which is nothing but the gravitational gravitational neutral point between the planets, two masses, which is the center of mass, lies outside the sun. For all other planets and the sun, it lies inside the sun, but the center of mass, or you can say the barycenter, for these two planets, Jupiter and the sun, lies outside the sun, which itself tells us the uh, gravitational power of the Jupiter. So if you didn't know about it, let me I just told you this thing. So this will be launched via an Ariane 5 rocket in the French Guyana, which we will see today. So it will have in total 10 instruments, 85 meter square of solar wings, which is very much essential because it's going so far away from the solar system. No, sorry, from the sun. And the solar radiation which the solar panels would get would be drastically reduced, and so you need such a big uh, uh, area for the solar panels. And then finally it will have 35 Jovian moon flybys. This is not 35 moon flybys, it's just 35 times a moon will be flown by. So it's like that. So this is not only, this is led by ESA, but it's also contributed several international collaborators, NASA, JAXA, ISA. They have some hardwares of to this mission. And talking about, let's have a look at the Europa itself, right? Sorry, the juice itself, right? Before that, let's have a look at the Ariane 5. Yeah, let's get this away with. The rocket. Who does not know about the Ariane 5? The famous rocket which launched the James Webb Space Telescope. And it was such a precise launch that it itself saved some fuel of the James Webb Telescope and increased the lifespan of the James Webb Telescope by 2 to 3 years. So it's a very capable rocket, and it has flown so many times now, and I am very confident about this rocket now. Initially, when it was supposed to launch the James Webb Telescope, I was not so much confident, but after the success of it, yes, I am. So today it's gonna fly around 5.8 tons. That's the spacecraft mass. So the characteristics of this rocket is around 10 tons to GTO, but it's going interplanetary today. So there's that. It is powered by a Vulcan 2 engine, which you can see, one Vulcan 2 engine running on hydrogen and oxygen as its fuel. Produces a maximum thrust of 1390 kilonewton of thrust, and it's a regeneratively cooled gas generator cycle engine. Also, it has a cluster of gaseous hydrogen thruster used for roll control, which is very much required. But before that, it's obviously started at the time of the liftoff. But at the time of the liftoff, most of the work is done by these two dudes. So Ariane 5 has two solid boosters, around 238 metric tons of propellant. 90% of the launcher's total thrust at the start is provided by them, and because of that only it's able to sustain the, first of all, it's a hydrolox first stage, so ISP would be more. But still, since we can operate the first stage at a lower thrust initially, because the most of the work is done by the solid rocket booster itself, saves the fuel, and that's why the burn time of the first stage is very large. So talking about the second stage is powered by one HM7B engine, which you can see. The one you can say a con of this engine, but kind of it has not proved to be a con till now, is that it's not restartable. So if once it is ignited, it has to deliver it to the point which it has to go. So today also you will see it will be once it is restarted, once it is ignited, the payload will be deployed to its final destination. That's it. There will be no restart, which we see in the SpaceX Falcon 9 as well as the Centaur from the very famous Delta rockets, right? Atlas and Delta. So there's that, and it's also a gas generator power cycle and hydrolox engine. So this is pretty much about the rocket itself. Now let's move to the JUICE mission, the JUICE spacecraft. Okay, so we have, let me just, yeah, so there you go. So this is how the JUICE spacecraft looks like. So the JUICE is, it is actually gonna study, as I said, three large moons: the Ganymede, the Callisto, and the Europa. And this JUICE stands for Jupiter Icy Moons Explorer, and the spacecraft will carry 10 scientific instruments, one experiment, and one radiation monitor. So this is how it is. The mission will have several, it will break several records, including being the first spacecraft to orbit a moon other than our own. So talking about this orbit a moon other than our own is what is supposed to happen. So Europa Clipper, so let me give you the answer for that, the three missions to the Jupiter, right? There will be Europa Clipper, the Juno mission, and now the JUICE mission will be studying the Jupiter uh, system, Jovian system. So this will be the first time that a spacecraft will come into the orbit of a moon of another planet. So yes, this is going to extensively study the Ganymede, which is the moon of the Jupiter. And one beautiful thing about Ganymede is this is the only moon in the whole solar system which has its own magnetic field. And because of its own magnetic field, there are such a good interaction with the magnetic field of the Jupiter as well as of the um, Ganymede, that the auroras, which if this one, what should I say, Ganymede had atmosphere, you will see the auroras where it will form. I'll show you. I'll show you, but that is one of the interesting facts about it. So let's have a look at these scientific instruments, right? So we have 10 scientific instruments. So first of all is genus, which you can see here. If you can see, this is the genus. This is nothing but an optical camera system. It will look this will look at the global, regional, and local features of the moons and the maps, and map the clouds of the Jupiter. That is one thing. The other one is the magus, which is this one here, located here. It is nothing but visible and infrared imaging spectrometer. This will study the clouds and atmosphere of Jupiter as well as the ice and the minerals on the surface of the moons. Next we have the UVS, which is here. So the UVS will study, this is a instrument contributed by NASA, and it will study the composition and dynamics of the moon's exospheres. Okay. And then so studying the aurora and basically all those things. So next one we have the submillimeter wave instrument, SWI, uh, located over here, which will study the temperature, composition, and dynamics of the atmosphere of the Jupiter and all those things. Then there will be three geophysical instruments: radar sounder, which is nothing but RIME, which is this big boom which is there. So this RIME will have, this is also contributed by NASA. This instrument is an ice penetrating radar which is able to study the internal structures of the moon up to a depth of 9 kilometers. So imagine a thing actually flying by, just not even in a orbit, um, and it's able to study and look at the composition beneath the surface. So and that too till 9 kilometers. So till 9 kilometers, this is the instrument which is I'm actually most excited about, because why we are going to the Jupiter's icy moons? Because there is water. There is supposed to be a water beneath those ice crust. And if there is water, which we have seen also, like in um, Callisto, I guess. Not Callisto, it's Europa or Callisto. I'm not so I can't remember right now, but we have seen volcanic eruptions, not like exactly volcanic eruptions of the hot plasma coming out of it, lava coming out of it, but streaks of water vapors. So we are very excited. I am also very excited because in these icy moons there is supposed to be water beneath it, and if there is water, there can be life also. Water is the foundation of the life, and if there is a, like you can say, a thick layer of crust which is there, right? um, Ice crust, then actually life can survive there, because the radiation is the only thing which the 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 life cannot have. It cannot survive on the radiation, and if we have a thick layer of ice, then the radiations can be blocked. So who knows, we might find some microbial life there, not some fishes or sharks there, but something. At least we are not going there right now, but we get to know for sure that there is water beneath those ice crust. That's what this rhyme is gonna do. Then other one we have is the laser altimeter, which is nothing but the gala is here. So this is contributed by JAXA, and this will study the surface of the moons and the tidal deformation of the Ganymede. Then we have the radio science instrument, which is this three inside the spacecraft 3GM. This is ISA has contributed this one, and this will look at the gravitational field of Ganymede, the internal oceans of the three moons, and the atmosphere and the ionosphere of the Jupiters and the moons. Then we have the magnetometer boom. Obviously, this will study the magnetic field. Then we have the particle environment package, or PEP. You can see here. This is gonna study the plasma in the Jupiter system. Then we have radio and plasma wave instrument, which is nothing but here only RPWI. This will also study the radio emissions and plasma in the Jupiter and the moons. So this is all the scientific instruments which it is carrying, but rhyme is the one which I am very much excited about. And obviously the optical instrument, the Janus, which is going to take some pictures for us. So yeah, this is the thing. Now let's move on to the next part, which is the journey. The journey, how this um, juice mission is gonna go to the Jupiter. And as you know, we have plenty of time when it comes to space. We are not living in the expanse world, so we take care. We use the gravity assist, the free gravity assist, the free acceleration which we get when we come near the planets. We are going to use that. Okay. So how are we going to use that? So first of all, let me tell you what is a gravity assist. This is nothing but a slingshot effect which is there. So we have gravity, a planet has a gravity in it, right? So if a spacecraft which is roaming freely in interstellar space comes near the gravitational sphere, I should say inside the gravitational sphere of a planet, then it will impact the acceleration, because it will start falling towards the planet. So it will impact the velocity which it was flying. So it will add the velocity towards it, and because of that will work as an engine. And because of that we can increase the orbit of the spacecraft. Well, this can, or if you are thinking about the reverse scenario, whether the slingshot can decrease the velocity, yes, it can decrease the velocity also. So this is a beautiful mission in which we gonna see both the things, the increase of the velocity as well as the decrease in the velocity. So let me tell you how this is gonna work. So first of all, the launch will happen today, the launch April 2023. Then in after a year, it will be the launch into interstellar space, but after an year it will come for the earth moon gravitation assist on August 2024. Then it will go to the next year, it will reach the Venus, it will take gravity assist from there. And then again at September 2026 it will again reach the earth, take a gravity assist from there. And then finally at Jan 2029, 3 years after that, finally for the last time it will come and say hello to earth. Earth, she will be a nice mother and give her child nice push, so that finally it can go to the Jupiter, which is, you can say now, the transfer Jupiter orbit insertion in July 2031. So this is a very very long mission, around 8.5 years of cruising phase and around 3 years of science life. That's how it is supposed to work. So once it is inside the Jupiter, it will do the transfer to Europa. So what I was talking about, so this in these phases 1 3 4 and 1 2 3 4, it is adding to the velocity of the spacecraft. At the 5 1, the Jupiter orbit insertion, it's not using engines here also. It's gonna take the help of the Ganymede to insert inside the orbit of the Jupiter. Now here it will slow down using the gravity assist. Very beautiful, right? With the help of the planets only you can travel into space. Wow. And it just amazes me that they have planned it out so well. And this is gonna work also, because the planets will be there. If the velocity and the trajectory is matched, it will be there to assist us, and then all things will uh, follow one by one, and we will have our final destination. So okay, let me again explain what is going to happen once it is inside the Jupiter. So it will initiate the transfer to Europa. Here it will do some burns and all. The Europa phase will come here, and then finally it will study the Europa here. After that, the Jupiter high latitude phase to study the Jupiter properly. Here it will study the Europa. Here it will study the Jupiter, and then finally it will transfer to the Ganymede. And during the Jupiter high latitude phase, it will also study the Callisto, and then finally it will do this transfer to the Ganymede. And once it does the transfer to the Ganymede, it will insert itself into the orbit of the Ganymede to study the Ganymede, and stay there until unless the battery runs out, the fuel runs out, and all those things. So there is no battery. There is a battery, but there is a there are solar panels also, but who knows, battery becomes faulty, then how do you store the energy, right? So this is how it is. So this is the whole journey. This is a pictorial representation. Now let me show you the animation so that you can better understand what is gonna happen. All right. Okay, so let me just wait a second. Over here, I'll explain you, don't worry about it. So I've already explained you will get to know. So the juice has launched, right? It will stay for in the orbit, first orbit around the sun, April 2023 to August 2024. It will again reach the Earth here. You can see it will take the moon lunar gravity assist as well as the Earth gravity assist. So after the Earth gravity assist, it will do again a second orbit around the sun and go to the Venus. You can see here, take the gravity assist of the Venus. And after that, the Venus, it will go for one more orbit around the sun and then come to the Earth. It will take the Earth gravity assist for one more time to increase the orbit. You can see the orbit is increasing. And then finally, after 3 years, it will again come back to the Earth and take a gravity assist with the Earth again, and this time to have the final push to the orbit to reach the orbit of the Jupiter. So doing a final goodbye to the Mother Earth, right? And there you go, final push and off to the Jupiter. So once in Jupiter, it will do a Ganymede flyby. So there will be around 31 flybys of the this moons. So all these flybys have been made, have been extensively calculated, so that they know which planet, which moon is where, and they can use the gravity of the moon to their advantage to go to other destination. So this calculation and all, I am just a very it's very complex, and it just boggles my mind somehow that people can actually do all these calculations and make sure they reach the destination. So this is the thing which I was talking about, orbit energy reduction phase. reduction of the velocity. Europa flybys to study the Europa, the scratchy planet, right? So, okay, have a look at it. Then we have a Callisto flyby. Study the Callisto here. High inclination phase to study the Jupiter as a whole, Jupiter system, and Jupiter as a whole. And then you can see it is trying to increase its inclination so that it can have a look at the upper part of the Jupiter atmosphere also. Then now here it will do, you can see now Ganymede orbit insertion. Yes, now here for this part only, most of the time most fuel will be used here only, the Ganymede orbit insertion, so that it can actually insert itself into the orbit and then lower circularization of the orbit around Ganymede and then study Ganymede for whole. So this Ganymede also is a icy moon, right? But it also, why they have chosen this to orbit, because it has its own magnetic field, and they want to study the interaction of the magnetic field of Ganymede with the Jupiter, which is going to help them a lot, because then they will be able to understand the interaction of the moons of the gas giants of other solar system, how the magnetic field and all those things happen. And then finally at the end they will impact into the Ganymede, which itself will be very exciting to see what is going to happen when they are going to impact, whether a shark would come out to eat the spacecraft, or what would happen, right? Because we don't know, there might be some life underneath the icy crust. Okay, now moving on. So we have had we now know how the journey would look like. So now this is how the unfurling of the JUICE spacecraft would look like. So here you can see that. So first of all, the solar panels will open once it is deployed into the space by Ariane 5 today. So this is 85 meters square of solar panel area which is there. So you can see, and this is a T-shaped kind of solar panels, which is and the Juno had three solar panels. It has two, but it has like plus shaped, I would say, solar panels there. Then it would deploy other scientific instruments. This is the RIME, which I am most excited about, right? You can see this is how it will be deployed, and it's a very delicate maneuver. So kudos to them. If obviously they will be successful in all those things, but to package all those things into one thing and then finally deploying it, a very uh, good thing to do, right? Then the magnetic boom will come. Here you can see the magnetic boom. It's always placed outside, as far away from the spacecraft as possible, so that the spacecraft's magnetic field is not it is not interfering with the magnetic sensor of the magnetic boom. And then others instruments would deploy. This will happen very slowly, although this is like has happened within minutes. This all things will happen really very slowly within a span of few weeks. And yes, so how it would look like. Moving on to the next part. So this is what I was talking about. So if you see this here, uh, the Ganymede, since it has its own magnetic field, so if it had atmosphere, right, where would the auroras form for the Ganymede? Let's see that.
There's the internal magnetic field of Ganymede. Ganymede's the only moon in the solar system that's got its own internal field.
There you go. Since the interaction of the magnetic field of Jupiter and the Ganymede is like this, because the Jupiter's magnetic field obviously overpowers the Ganymede magnetic field, the the poles are actually at the kind of near the equator. How cool is that? The magnetic poles of the Ganymede are actually near the uh, equator because of the Jupiter. If it had an atmosphere, the auroras would have formed there. So everybody who are living near the equator would have seen these auroras. How cool is that, right? Do these gravity assists have a burn at periapsis? Bogey hole troll says. So it all depends on the requirement. So gravity assist usually does not have. So what happens during the gravity assist? So gravity assist itself does not have any burn. So the gravity assist will happen, and after that, the trajectory correction maneuvers will take place. So there won't be any burn at the periapsis until unless you want to drastically reduce something, or like go inside the orbit of the Ganymede, which they will do. There they will turn on the engines. Otherwise, the engines will only be turned on for the trajectory correction maneuver and all those things. Okay. All right. Now, since we have talked so much about these moons and all of the things, let's have a look at the moons itself, right? What these moons are all about. So, first of all, we have the Io. This is it's not going to study Io, but this is a volcanic moon which has a lava crust onto it, which you can see. So lava is there inside the Io, and it literally spews out lava from the active volcanoes. And then the scratchy planet Europa comes in, which itself is an icy moon. Here you can see the ice crust, the core, and then the liquid water, which you can see. So this is what it's gonna study inside of it. And then the Ganymede, again, a core which is magnetic, which generates magnetic what should I say, field. And then the other core, and then finally the liquid water, which we are assuming for now, but we are very sure kind of the liquid water exists. And then the icy crust. And then we have the Callisto, which is known to be the most kind of hit by the asteroid micrometeor. So it has this the spots which you see, right? This is the because it is preserving all those hits, micrometeorites hits, or the asteroid hits on the surface. And studying the surface of this will show us, will uh, you know open up so many opportunities to see what it actually contains, what the earlier solar system was, and all those things. So again, it also has liquid water, which that's we are supposing. It does not have a proper core, you can see, but still it has a liquid water. That's what we are assuming. So everything is very cool, right? All right. Now move on to the next thing, which is, so all the things related to the JUICE and Jupiter JUICE mission must be clear by now. Let's have a look at the flight sequence for today. So we have this one. So as I said, it's around 6 tons. That's the mass of the spacecraft. And the mission profile would look like, again, a typical mission profile for Ariane 5. Liftoff would happen at t plus 0 seconds. The solid boosters will separate at 2 minutes 16 seconds. The fairing jettison will happen at 3 minutes 9 seconds. Till the first stage is firing at t plus 8 minutes and 44 seconds. The first stage will shut down its engine because of it has depleted all its fuel. Then the second stage will come into place. The cryogenic upper stage ignition happen at 8 minutes 49 seconds. And then once it happens, it will go all the way to the orbit. You can see actually the orbit also kind of increases and then decreases and then increases. So this is a typical profile which Ariane 5 only has, because the upper stage does not have much of thrust. It only has 67 kilonewtons of thrust. So it uses a very ingenious way of accelerating by going to the apoapse first, and then coming down into the earth, so that it accelerates. It takes the help of the earth, and once it reaches this point, it has depleted some of its fuel, so it can provide proper thrust to the spacecraft, and then again it rises. So it is a very cool little maneuver which it performs because of its lack of thrust, but again, no problem with the rocket. It has a way of overcoming that. Okay, so the velocity, infinite velocity, 2.5 kilometers per second. Okay, sure what is that, but yeah. Uh, so now the final launch kit, which will summarize everything. So we have seen already all these things. So this was the mission milestones, which has happened, which will happen. So we have talked about all of this. Juice in a nutshell, we have talked about this, right? So investigate Jupiter's complex environment, Jupiter's icy moons, so all those things. Five mysteries Juice will address. Why is Ganymede so unique? Why are ocean worlds like? What are ocean worlds like? How has Jupiter's complex environment shaped its moon, and vice versa? Could there or ever have been life on in the Jupiter system, which it will discover? With this is what I'm most excited about. And what is the typical gas giant planet look like? So this is all those things. Then finally the icy moons it will explore. uh, Magnetic things, the Jupiter and its complex environment, the basically the Jovian system as a whole, it will explore. So there is that. Then we have Juice's scientific instrument, which we have already talked about. uh, so obviously it will have shields and solar panels, the harsh temperature. This is what it has. This is the long distance antenna, um, which is kind of very directional, but has low power and is very directional. So it has the antennas on earth has to be pointed directly towards this spacecraft to capture any signal. So it's highly directional basically. The long distance are highly directional. So this is a Jupiter mission timeline which we have seen. So presently this is the thing, the Juno, Europa Clipper and the Juice. So kind of you can see that Europa Clipper, once it Europa Clipper as well as Juice both will operate kind of during the same period. And yes, they, rather than competing with each other, they will complement each other. And yeah, so trio missions will be there. All these things we have already talked about. Okay, just a second guys. Right. So quickly I'll have a summary for you so that you can actually have a look at what all things are gonna happen, and the Juice mission as a whole basically. So just listen in.
JUICE is the Jupiter Icy Moon Explorer. So it's the first large mission of the Cosmic Vision program of the European Space Agency, and has the is the Jupiter Icy Moon Explorer. So it's the first large mission of the Cosmic Vision program of the European Space Agency, and has the objective to study the Jupiter system and three of the Galilean moons, three icy moons, which are Europa, Ganymede, and Callisto. The scientific objectives of JUICE are multiple. So first of all, we have humanity always poses itself a question: are we alone in the universe? Is there life outside Earth? To respond to this question, first we need to answer to another question: are environments where life can be sustained before going and search for life? And this is one of the main objectives for JUICE, to search if on the environment, on the ocean world of Europa and Ganymede, there are the conditions to sustain life. The other objective of JUICE is to study the Jupiter system in its integrality, as seen as a miniaturized solar system, if you want. We have a gas giant with bodies that go around this body, and studying the interaction of the gas giant with these bodies, we can understand better, for example, the development of our solar system, how it was born, how it works, and etc. We have 10 instruments on board of JUICE, and all of them are extremely important to provide the full investigation of the Jupiter system. So we have instruments that can cover the full range of frequency from direct current up to the ultraviolet. We have a laser altimeter to perform all the altimetry, the detailed altimetry of the moons. There are particle package measurements. There is the sounder, which is this long deployed antenna that you can see that will investigate the subsurface structure of the moons. So there are radiation monitors. So there is a full package for an analysis of the Jupiter system and the 3 ESA moons.
All right, so this is what it is. I think they are live now. I'll switch over to that.
JUICE was ready, the launch was ready, but the weather was not with us. You know, we have to monitor two risks, high altitude winds, and it was okay, but risk of lightning yesterday was a real risk with the cloud to monitor, and so we have made the decision not to lift off yesterday.
But of course, as we always say, better be safe than sorry. JUICE can absolutely afford to wait another day under the fairing, not a problem.
Yes, for sure, because you know that once we will have done our job, after 27 minutes, and once we will have orbited JUICE on an escape orbit, then it will be the start of an 8-year journey. So one day is nothing as compared to what we have ahead of us. We will monitor the weather now in the final minutes. The teams have worked all night. All is red up to now, so we are now... All is green up to now, sorry.
And we can see it on the status board, and we get some clapping here from the crowd.
It's a part of emotion for such an important mission.
It's going to bring us very good luck.
Yes,
absolutely.
All is green. And so at 9:14, we will lift off.
At 9:14, we'll lift off. Thank you so much, Stefan, and fingers crossed, good luck for today. And we'll see you later. Thank you so much, Stefan. And Stefan is getting a round of applause in here in Jupiter. Of course, an emotion which is easy to understand, obviously, considering the conditions of yesterday's delay. But everything is fine, safe and sound under the fairing, as we said. So, as the teams working here in Jupiter Control, more than 7,000 kilometers away over the Atlantic at ESA's Mission Control Center in Darmstadt, Germany, we have the teams there who will take over control of the aircraft once it separates from the mothership. And we're going to go straight over and speak to them and hear how things are looking over there in Darmstadt. Over to you, Matt.
Thank you, Lisa, and hello to all our watchers. Welcome to ESOC, the European Space Operations Centre, here in Darmstadt, Germany, in the heart of Mission Control. I am. My name is Matt Russell, and I will be your host for the second half of this JUICE broadcast. And behind, we have Bruno Souza in the actual control room itself. So, hello, Bruno. Try and give us an update of what's happening in there at the moment.
Hi, Matt. We're still getting goosebumps all day, although to this time a bit more cautious goosebumps. But we are ready to go. And in fact, just a few minutes ago, the flight director, Andrea Komatsu, just did the roll call and got to go from everybody here in the room. We have some footage of that, and we're going to replay it for you.
To all stations, this is OD on the briefing loop for the roll call. Please reply on my call with your call sign and your status go, no go. OM.
OM. Go.
Some
go.
Data handling.
And data handling go.
AOCS.
AOCS go.
Platform.
Platform go.
Flight dynamics.
Flight dynamics go.
Project rep.
Project rep go.
Project support.
Project support go.
Softcode.
Softcode go.
Software support.
Software support go.
S-Track.
S-Track go.
Scheduling.
Scheduling go.
Thanks. This completes the roll call for the JUICE mission. We are go for launch.
So as you just saw, we are fully ready to go. We're just waiting for that rocket to get off the launch pad.
Thanks so much, Bruno. Well, we're running out of time here, so we're back over to you, Lisa, in Kourou, and massive good luck to you.
Thank you from the teams in Darmstadt. And hey, the pressure's on. They said all we're waiting for is that rocket to take off. Well, they've told us they're ready. The rocket is ready, but we want to know about JUICE. And we have Mihaela Barbeau from ESA who's here to tell us all about it. Mihaela, how ready is JUICE?
Good morning. JUICE is actually ready and excited to start this journey. As we speak, my colleagues are closely monitoring the satellite. So yesterday, after the launch postponement, the satellite was switched off. And slowly in the day, around 7:14 p.m., it has been turned on to start the countdown procedure. They are very close to us, a few kilometers away in LBC control room, and everyone is hoping for good weather specs.
Fantastic. So we have a bit of time to chat about this. So your job is schedule controller. Does that mean that you're in charge of making sure all goes to plan?
It's part of my responsibility, but you know, when it comes to scheduling, it's never one single person's job. It's actually a team exercise because planning means working coherently as a team. And us, the JUICE project team, we are quite schedule-oriented. We have a strong planning mindset. And even if you have the most perfect plan, you always have risk, you have uncertainty. And we saw that yesterday. So imagine if you take a step back, us in JUICE, we had to run our AIT campaign through a pandemic. And if you think of the industrial consortium, more than 2,000 people worked on this program, 23 countries, 18 institutions, 83 companies, then you understand the complexity of project management that my colleagues and I have been performed on this mission.
And done a fantastic job so far. So this is a personal journey for you. It's 8 years, your entire professional life, because you're just a baby. So tell us how you're feeling today.
I'm very excited, and yes, JUICE is my entire career in ESA. And yesterday, as the project team, we received so much positive energy from home, from our science project. Thank you so much for your wishes. Everyone in ESTEC, we saw you how many were there. Thank you for your support. ESOC, ESAC, the people on the spaceport, we managed to see our extended JUICE family, our instrument colleagues, and we spoke with them. So they gave us all the energy to go through the night and to keep JUICE ready for the launch today.
Thank you so much. Have you got a last word before we leave it here?
I wish everyone to enjoy the launch from all the teams who have worked on this amazing journey. As European, I'm exceptionally proud to be part of it. And let's enjoy the event of today. It's well-deserved. Absolutely well-deserved for your teams and, of course, all the other teams that you mentioned that have been working on this project. Thank you so much, Mihaela. Thank you. So as Mihaela was saying, a huge amount of work from teams all over the world. We're going to find out more about these teams' achievements and, of course, about JUICE in the next film.
Jupiter, the largest planet in the solar system, is a place that holds many secrets. This fascinating gas giant planet and its intriguing moons have raised more questions than answers. Today, these answers are in ESA's grasp, with the very first European mission to Jupiter, JUICE. Short for Jupiter Icy Moons Explorer, this spacecraft will explore Jupiter and 3 of its icy moons, Callisto, Europa, and in particular Ganymede. Developed and built by Airbus, JUICE's spacecraft is equipped with 10 top-of-the-line science instruments to explore the Jovian system and investigate whether some of its many environments may be suitable for the formation of life. This grand odyssey of exploration begins with the launch of JUICE on an Ariane 5 rocket from Europe's spaceport in Kourou, an historical mission aiming at solving key mysteries such as the possibility of life in the Jovian system, Ganymede's magnetic field, and last but not least, the formation of Jupiter and its moons. JUICE will also study Jupiter's complex weather, chemistry, and climate in detail.
It's a very fantastic mission from the scientific point of view. Very broad science, very interdisciplinary science. We would like to see whether around Jupiter there are places where life could have started. To explore that, we need to find a place with internal energy and with liquid water. And inside the icy moons, we have good reason to believe that there is in fact more liquid water there inside the surface than on Earth.
JUICE is expected to arrive at Jupiter in 2031 and will then make its Jupiter tour and moon's flybys before orbiting Ganymede. This will be the first time a spacecraft orbits any moon other than our own. During its journey, JUICE will face many dangers such as Jupiter's intense radiation belts or its large gravitational pull, but these dangers will be worth it for the science that JUICE will uncover. The gas giant will reveal some of its many secrets in 2032 when the first data will be available. Watch this space.
So speaking of space exploration, we have two of the faces of human space exploration with us here today. I'm delighted to welcome once again Thomas Pesquet and Matthias Maurer. Thank you very much, gentlemen, for being with us again today. It's a pleasure. So we're seeing JUICE go up into space with these outstanding instruments. What is it about sending this kind of instrument, going out to space yourselves, that helps us back here on Earth? First question to you.
Yeah, I think space exploration really in space ticks all the boxes. You've got all the short-term benefits, you know, the things that we all use, that we all have in our smartphones, the navigation, the weather report. And then you have the more medium-term, I would say, applications. The reason we know today about climate change, the reason we're in position to fight climate change is thanks to all the missions we send around the Earth and observing the Earth. So that's kind of the more medium terms. Space agencies are the champions of fighting against climate change. And then you have the longer term, the far-reaching benefits for the future. And that's the research and the exploration we're doing, the research on board the space station, building better materials, you know, better medicine, better treatments. And it all diffuses in society on Earth and it's going to make the progress, you know, go up one step at a time. And then those missions going far out into the solar system, it's really to look at ourselves, our place in the universe, how do planets form, where do we come from, where are we going? Those are very important questions, and those are the type of questions that we're trying to solve with those missions.
Fantastic. Well, we're talking about JUICE today that's about to lift off and go on its mission, a long, long journey. But what about human space exploration? What are the next destinations?
Well, I think the next destination is very much the moon. I mean, the next big thing in space exploration, human space exploration, is the Artemis program. ESA has a big part to play in the Artemis program. We're providing the European service module to the Orion capsule. And that means one day we'll see European astronauts around the moon, on the moon. And so to prepare for this, we also have our robotic moon exploration. And then what we learn on the moon will put us in a position one day to go to Mars. And Mars is the twin sister of the Earth. That's where we learn a lot on ourselves. It had similar conditions. It has lost its atmosphere. Liquid water also has disappeared. Can it happen to us? You know, those are important questions. And that's why we'll go to Mars first with our probes, with our orbiters, and then one day with human exploration to Mars. That's the big prize money, the big goal, the big step.
Fantastic. Wow. It makes you dream. But of course, what I would like to know from you, Matthias, is are you guys getting ready to take part in these adventures?
Yes, so Thomas and I, we already flew to a low Earth orbit and flying to the moon. We need to learn more because on the moon you need geologists. So we need to go out in the field and learn how to talk with the geologist, how to be the hands and the eyes of the geologist once we're on the surface of the moon. And ESA already started this training for European astronauts some years ago. And so we see continuously European astronauts going out into the field, learning all these skills. But we also need to develop facilities where we can train European astronauts what to do on the moon. And so in Cologne, we will now have the moon training facility, which will enable to do all this training over there. And it will be so good that even hopefully the NASA astronauts will come over to train there, for their Artemis mission. So that's the big vision that we have. But it's not only learning for the moon. We also should also keep in focus that we have European astronauts flying to the ISS. Andy Mogensen is getting ready to fly later this year. And we just started a new astronaut class. They will be flying to the ISS, hopefully, and to whatever comes after the ISS.
So do you imagine yourself taking off from here from the European spaceport here in French Guiana one day, Matthias?
Yes, we are currently in times that are really like a revolution in space. And so Europe needs to step up. And one of the big missions that we have, we need to become sovereign, to become autonomous, also with access to space for Europeans from European soil. And I think French Guiana is the ideal place to send Europeans on a European rocket in a European capsule to space. It's our big dream. Thomas and I, we would love to fly together from here to low Earth orbit, but maybe even also in a European rocket further towards the moon.
And you said you'd be happy to welcome your NASA friends as well.
Absolutely. I mean, it's like we should not forget spaceflight is also a soft diplomacy power. And we will see very soon that China will invite foreign astronauts to fly to their space station. And so we Europeans, we are just learning that in these times it becomes more and more important to be be on level field play.
All right, guys. So we are T-minus 13 minutes from the launch. Everything is looking good. Although French Guiana is known for the lightning and rains and all those things, but right now it's looking good. If you can see the dashboard which we have, it's all green, so that is good to see. And since there is so much forest around the spaceport, it is bound to have rains and all those things. So we are hopeful this is gonna launch today, and let's see what's gonna happen. I'm very excited. Let's hope this mission is successful, and we will send another spacecraft to the Jupiter today.
Talking about those because it's so important, and yes, we're working on it. But let's talk about JUICE because that's why we're here. Also another excellence where Europe is really good, and let's look how our satellites and our launches are doing.
Thank you very much, gentlemen. Huge thank you.
Thank you.
And to talk about JUICE, I am joined by Raphaël Chevrier from Arianespace. Raphaël is going to take us step by step all the way through every step of the mission. Raphaël?
Hello, Liz.
Hello. Welcome to Road to Space, and I'm going to let you take over from here and tell us what the next steps are.
Yes, so this morning we are launching towards the east,
all green, yes,
where we benefit from the slingshot effect given by the rotation of the Earth. So the launcher performs a first pitch maneuver in order to get us into the right direction. And only 2 minutes and 17 seconds after liftoff, the two boosters have done their jobs of providing the main thrust, so we don't need them anymore. They are detached from the launcher. Shortly after that, the fairing, which protected the spacecraft from the environment of the launch, is also jettisoned as we have crossed the limits of the atmosphere. Once the launcher reaches an intermediate orbit, the main stage is cut off and separated. So then the upper stage takes over, which engine is going to power for about 16 minutes in order to raise speed and altitude and release JUICE on the targeted orbit. So, by the way, the little towers that you see on the motion picture, they represent a chain of telemetry stations that are receiving data from the Ariane 5 in real time all along the flight path. After some orientation maneuvers, JUICE is separated on a liberations orbit. It means that it will have the required speed to escape literally the gravitational pull of the Earth. Then this is almost the end of the mission from the launcher, as we still need to perform some disposal maneuvers of the upper stage, but JUICE is only beginning its journey. ESA teams will use the Norcia ground telemetry stations in Australia to acquire the signal from the spacecraft and take full control of it. 1 hour and a half after liftoff, Joule will start deploying itself like a butterfly into space. First, it will unfold the large solar panels. Their total surface is 85 square meters. This is definitely bigger than my Parisian apartment. And then, in the following days, it will deploy its many antennas and probes. So the animation here doesn't depict the increasing altitude that JUICE is going to get, getting farther and farther from Earth on its way to its 8-year journey to Jupiter.
Thank you so much, Raphaël. It's all very clear. And actually, as Raphaël was speaking, so you can see the pictures of Ariane on the launch pad. As Raphaël was speaking, we hit the next milestone in our in the chronology, which is, of course, the -10 weather update. And
yes,
I'm looking at the board. All is green. I
all
have
is green right
had
now.
anything in my earpiece. I don't see anyone picking up a mic. So it's looking good so far.
It is green and we're good to go.
Looking good to go.
What we check, like Stefan said, we are usually checking the wind at high altitude, the wind in the vicinity of the launch pad, and also the risk of lightning. Yesterday, it is the risk of lightning that prevented us from launching, but today, everything's good. We're good to go. We can continue the operations.
That sounds great. And continuing the operations means that we're heading towards what we call the synchronized sequence. We'll talk about that in just a minute. So there's another team. You see the teams working here. Final preparation underway here in Jupiter Control. But of course, there's another team at the Launch Control Center, which is much closer to the launch. It's about 3-4 kilometers to the launcher. And they've been working since last night. They've not slept. Tell us more about them.
Well, these teams are monitoring all the operations during the final countdown. So, for example, they are filling the cryogenic stages.
Hi, John. Hi, Campin, and hi, Dev Pratim. Welcome to the stream. Yes, this is a penultimate launch, and hopefully, and I think this is the last launch for ESA with Ariane 5, and then it will be replaced by Ariane 6, which is more capable, more reliable. That's what they say. Let's see how it performs. But Ariane 5 and the legacy will continue forever, for sure.
Raphael.
Well, it's a real crucial step.
You have 30 seconds.
Yeah. So I'm going to make it very quick. It's basically a succession of operations aimed at giving more and more autonomy to the launcher and to set it in its flight configuration.
Yeah, because it is irreversible.
Campaign.
Once we've started the synchronized sequence, we can't go back.
One more is there.
So we are going.
Absolutely. And we're going to now wait and hear.
À tous de DDO, attention pour le début de la séquence finale lanceur. Top H0 moins 7 minutes.
So there we heard it from the DDO, who is the Range Operations Manager. We'll talk about him in a minute. And he's just announced the start of the synchronized sequence. Just a quick question. Why does it have to happen at -7? We were just saying.
Well, I mean, this is obviously not a magic number. This is just the time for all these last-minute operations to be performed. For example, we are topping up and pressurizing the tanks. We switch the power supply from ground to board, and only then the launcher is going to be fully awakened for launch.
Fantastic. For those who are joining us, we are 6 minutes and 20 seconds to liftoff of Ariane 5, carrying JUICE on the first leg of its journey into space and towards Jupiter. As Raphael was saying, Ariane, we were talking about this earlier, Ariane normally launches 2 passengers, but this time it's a single passenger. So can you just go quickly into what difference that makes for the launcher?
For the launcher, this is a very precious passenger, but for the launcher, it remains exactly the same. You have the 2 lateral boosters, you have the main stage, you have the upper stage, 1 fairing. We are also launching towards the east, which is the same direction as for standard telecommunication satellites. Only the final destination is a bit different. This is Jupiter. It is the last time that we performed such a single configuration. One of the last time was for launching the Space Telescope James Webb. Let's hope today is going to be as flawless and smooth.
Absolutely. And let's quickly now go into the film and have a look at the last couple of months of launch preparations.
Near the launch pad, because this is actually in the center of the forest. So, yeah, that was a little sloth, right?
Is sitting safe and sound, tucked under the fairing, as you can see, waiting for liftoff in just over 2 minutes.
And you can see all of them are outside to witness this historic launch. We are T-minus 2 minutes, 20 seconds from the launch. Everything is looking good. The board is green. That means range is supporting. The weather is green. And we are looking good for the launch.
They are among the lucky... Oh, sorry, I didn't realize you could actually see us. We're sitting here in our skybox. So they're out on the terraces.
Very unlucky people who are doing the commentary, right? They can't see this beautiful launch going to the Jupiter.
You feel it. What are we going to see in the last few seconds before liftoff, Raphael?
Well, everything is going to happen quite quickly. So, like I said, the electrical power supplies switch from ground to board. The cryogenic arms, which are feeding the upper stage with fuel, we see them retract 6 seconds before liftoff.
Everything is green, guys.
We ignite first. We need to check
this is going to happen very soon.
Before we switch on the boosters, that's going to happen 7 seconds later. So don't be surprised if you don't see anything during these 7 seconds, because believe me, you will see and you will hear the launch.
And you'll be hearing every milestone being called out by the DDO. He is the Range Operations Manager, and his role is in an... Oh, we'll wait for the 1 minute mark. Raphael.
À tous de DDO, attention pour moins 1 minute.
T-minus 60 seconds
Top
remaining,
H0
guys.
moins 1 minute.
Everything is
Right.
go
So
for
from
the
here on,
launch.
no more commentary from us. Don't be surprised if it doesn't take off immediately, because of course there are those 7 seconds, Raphael.
Exactly.
During
So
which,
just enjoy the launch.
during which the Vulcan
T-minus
engines
45
are
seconds
set
remaining.
on, and then
All the best, Ariane
launcher
5.
takes off.
Godspeed,
Go,
Ariane
Ariane
5.
Go,
And
Ariane 5.
Godspeed,
Enjoy.
Juice. T-minus 35 seconds remaining. Yeah, this is happening. T-minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9,
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top.
ignition, coming to full thrust,
Allumage
and
EK.
liftoff.
Allumage EAP, décollage.
Whoa! Look at that beauty go. Still can't believe this is going to Jupiter.
La propulsion est nominale.
And into the clouds.
La propulsion est nominale.
I think it's nominal right now. Wow, that was amazing. Okay, picture perfect launch.
We go. We can. We've seen the Ariane 5 liftoff, roaring through the tropical sky, carrying Juice on the first leg of her journey into space, and now she has disappeared under the crowd. And see there, in Kourou, there are many places from which to watch these launches. As you can see, the beach, any place. And here we have a glimpse again of the rocket. Raphael, it's an amazing sensation for you as well, I'm sure.
Yeah, even with the clouds, it's just...
La trajectoire est nominale, tous les paramètres bord sont nominaux.
I hope we
It's
get the
really,
onboard
really
camera views.
always impressive. And
or the we need those data now.
so the DDO said that the trajectory is nominal, which means that it's working perfectly.
So at the next step is at 2 minutes 33 seconds we will see the SRBs getting jettisoned. So you can see now the velocity 1.9 kilometers second, altitude and distance is almost similar. Wow.
Information on propulsion, guidance, and trajectory.
Exactly, he's like an orchestra conductor, gathering all the informations and summarizing it in real time, and soon we'll have
there you
booster
go.
Separation.
For confirmation from the DDO.
Séparation des EAP.
Separation
So
has
the
happened.
boosters have been safely separated. This is great. They have provided 90% of the overall thrust of the flight, so they're doing the main job. And then soon we'll have the separation of the fairing. And by the way, you see a special drawing on the fairing right here. Children around the world were asked to submit artwork
La trajectoire est nominale.
inspired by Juice's epic journey, and on this fairing, we see one child's interpretation of Jupiter embracing our spacecraft.
Wow.
Everything is nominal.
Tous les paramètres bord sont nominaux.
All parameters are going
There
smoothly.
you go.
And there we have it. We've seen it in our 3D
Séparation preuve
animation,
confirmée.
and we've just heard it from the DDO.
Confirmed. So the fairing was used to protect the satellites from the friction of the air, but also from the noise generated during the ascent phase. We obviously need to safely separate the fairing, otherwise we would not be able to release Juice into space. It
La
also means
propulsion est nominale.
It also means that we have crossed the limit of the atmosphere. So Juice is on its way to be separated in about 24 minutes from now. So by the way, we will have so the separation of the cryogenic stage when it has placed the launcher on an intermediate orbit. after this. I can mention that during, and we can actually see it on the motion design, because this is 3D animations here, that during the ascent phase, the launcher is set in what we call a barbecue mode. So it's slightly rotating on itself at a speed of 0.7 degrees per
Le
second.
pilotage est calme, la propulsion est nominale.
So we do this so that every face of the satellite is equally exposed to the sunlight. We just want to avoid overheating in one particular side of the spacecraft, which could damage the instruments. And as a matter of fact, when the upper stage is going to be injected on the targeted orbit, it will also rotate at a speed of 0.5 degrees in one direction, and then at the same speed in the other direction. Again, to avoid overheating on one part of the spacecraft, exactly like, a barbecue.
Exactly. And of course, there are the onboard computers. What are they measuring right now, Raphael?
Well, they optimize the trajectory.
La propulsion est nominale, le pilotage est calme.
Everything is nominal, so they optimize the trajectory in real time. They minimize the propellant consumptions to bring the launcher to the intermediate orbit, targeted at the end of the main stage propulsion phase. And as a matter of fact, we are accelerating a lot right now. So within the next 3 to 4 minutes, we go from, 3.5 kilometers per second to more than 7 kilometers per second.
So how much is that per hour? Because you're the engineer.
25,000 kilometers per hour. And ultimately, juice will be separated at a speed of almost 10 kilometers per second. And it will be separated at an altitude of 1,533 kilometers.
Very precise. Okay. So the next milestone we are now waiting for, and we'll be hearing this again from the DDO, is the acquisition by our downrange station of Natal. That is located in on an island in the middle of the Atlantic. I'll just wait and hear that from the DDO. He may not have confirmed it orally, but by now it is.
Just to explain, all along the route eastwards, Ariane is tracked from the ground. So the launcher's functions and vital signs are recorded and sent back to a network of stations.
Okay, so now you can see the trajectory is getting flattened, kind of. So it will dip, it will reach the apoapse, and then again it will start climbing.
Of course, I did not mean Ascension. I meant Natal, over the border in Brazil, of course. That's the second downrange station.
And just so you know, in all, that's about 1,500 parameters that is collected.
Collected, my goodness. So that there's no way these 1,500 parameters can be analyzed in real time, Raphael. What happens to them?
Well, the complete analysis is carried out in the weeks following the launch by a dedicated team. They provide a wealth of information about
the next step is the first stage separation. It's coming up at T plus 8 minutes and 20 seconds.
Improve our knowledge of a launcher, launch after launch. And then that's why Ariane 5 is such a reliable launcher.
And so you were talking about the stations, and it's a little bit, you were saying to me earlier when we were chatting, it's like a relay race, these stations, isn't it? These downrange.
Yeah.
You were listening to the DDO. What did he say? I didn't hear him.
He said that all the parameters are working perfectly.
Nominal, that's what we like to hear.
So the flight is perfectly smooth. So yeah, this is like a relay race with one telemetry station passing the baton to the next one, because we want to keep full visibility of the launcher in all dynamic phases of the flight. So the first stations to pick up the data was Galileo, right here in Kourou, followed by Natal in Brazil, then the island of Ascension.
Altitude has started decreasing, which you can see right now. It has reached the apoapse already. Now it is, you can see the velocity is increasing rapidly now. Now there you go.
Very short sequence right now.
We'll have the stage separation and stage ignition. There you go. Finally. Hopefully now this is going to Jupiter for sure.
Séparation EPC.
And the ignition coming up.
Yep.
There you go. It is trying to do a maneuver so that it is providing thrust on the upward direction so that it gains the altitude very quickly.
Because we forgot to mention that we are now in the sky booth, where we have a fantastic view over Jupiter, where we can see the crowds gathered. And yes, and so you cannot see the smile on Raphael's face, but he is delighted that this stage has gone perfectly.
Yeah, the ignition of upper stage is absolutely key, because it's always quite a little bit tricky to ignite a liquid stage in the emptiness of space. Sorry, I told you that on the ground we wait for a few seconds to check that the Vulcan engine is correctly ignited
Fin de visibilité par la station de Galileo.
Before liftoff.
How much
but
it
in
will
space,
dip?
it's just not possible to do that.
196 kilometers, 150, I guess.
The engine, also in zero gravity, the propellant is floating in all
Le pilotage
directions.
est calme.
The thermal environment is also not the same as it is on the ground. So, you know, there are many factors that make it quite
Trajectoire
challenging.
nominale, tout paramètre bord nominaux.
It's dipping, it's gaining a velocity not because not because of the engine, but because of the Earth's gravity also. But still, you can see the velocity is not so much increasing rapidly. So just imagine the thrust of the second stage engine.
Europe's best engineers are building on the success of Ariane 5, and there's already a fully integrated Ariane 6 on the launch pad.
Guys, just give all your best wishes to this rocket by hitting that like button, and hopefully this is gonna be a successful mission and we are gonna have another spacecraft into the orbit of Jupiter.
With the start of what we call the combined test, corresponding to the meeting between the launcher and the launch pad here
La
in
trajectoire
Europe
est nominale, tous les
Spaceport.
paramètres bord sont nominaux.
Here we see a fully representative version of Ariane 6, which has been assembled with the main core raised vertically, directed on the launch pad. The upper composite was then hoisted and mated on top of the launcher. This operational scheme is actually a big difference with respect to what is done with Ariane 5. It is made possible thanks to this mobile gantry, which will obviously be removed during launch. And also, 2023 is going to be also a busy year for Ariane 6, obviously. In January, the launcher was connected to the control bench, and a first power test was performed. Then dry run will be performed, followed by the actual fueling operations of the central
La
core.
trajectoire est nominale, tous les paramètres bord sont nominaux.
Teams will also perform hot firing tests of the lower stage engine, Vulcan 2.1,
This is
including a
the
non-firing
description which they are giving for Ariane 6.
of the upper stage were successfully performed in 2022 and beginning of 2023 in Lampershausen at the German Aerospace Center. Next ones
Propulsion
are
nominale,
under
pilotage
preparation.
calme.
So launcher elements that will be used for the Ariane 6 first flight will arrive in French Guiana using the new generation canopy vessel, which will be equipped with sails and hybrid
La
propulsion,
trajectoire est nominale, tous les paramètres à bord sont nominaux.
so that we can start the first real launch campaign of Ariane 6. And so today, the prototype of Ariane 6, stands on the launch pad, ready to continue the combined test. So good luck for this very ambitious and incredible program.
And Raphael, we heard while you were explaining all of this, we heard that the DDO called out a loss of signal with the Natal tracking station.
Suite à
Now,
la fin d'acquisition par la station de Natal.
there we go. And we didn't hear that it hadn't been picked up by the next station. Is that normal?
It is perfectly normal to have short visibility holes during non-dynamic phases of the launch. In this case, we have no visibility for just 63 seconds before the Ascension ground station picks the signal back. So this should come in any seconds now.
Acquisition de la télémesure par la station d'Ascension.
Your timing is perfect.
Confirmed.
So we've been picked up by the next downrange station, that is Ascension, the tiny little island in
La
the
trajectoire est
South
nominale,
Atlantic,
tous les
and
paramètres à
everything
bord
is
sont nominaux.
nominal,
147
us.
kilometers.
So from what I understand,
This is now the periapse for the whole orbit.
Yeah, Ariane 6 is already quite successful on the market, with already 28 launchers sold for both institutional and commercial customers. It is a very versatile, flexible launcher, perfectly suited for complex missions and satellite constellations deployment, thanks to its high liftoff capability and its reignitable upper stage engine.
La trajectoire est nominale, tous les paramètres bord sont nominaux.
Kind of, Daniel, yes. But they also have this regarding this missile launcher, right? We have Minotaur launches, which we have. That is a missile which is now launching the rockets, the satellites to space. So there is one which we are having, but I think Minotaur is also retired now. So we don't need those launchers now because we already have so many startups and private companies coming in. So yeah.
La propulsion est nominale, le pilotage est calme.
At the heart of the JUICE mission led by ESA is a giant bird-like spacecraft with large solar panel wings stretching out on either side of its main body. With a mass of 6,100 kilos at launch, JUICE is a heavy spacecraft carrying 10 high-precision instruments, including the most powerful remote sensing, geophysical and in-situ payloads ever flown to the outer solar system.
Building a spacecraft which has to fly around Jupiter is a challenge. To operate a spacecraft you need energy, you need power. And normally we get power from the sun using solar array. But around Jupiter there is not much sun. Therefore the solar array has to be very big. There is also another challenge. All the stuff that we built there has to survive very low temperature. And the third one is that the environment around Jupiter is very radioactive. That's why I think the solar array, which is very exposed and put together these three difficult technology, is really a great piece of engineering. Maybe a piece of art.
The instruments were contributed by the JUICE mission's scientific partner. The spacecraft was developed and built by Airbus, and Ariane Group's Savoir-Faire equipped JUICE with the chemical propulsion system that will drive it to Jupiter and its icy moons on an 8-year cruise.
We will provide the propulsion system for JUICE, which ensures that after leaving the launcher, it arrives correctly at Jupiter's moon and can work properly there. It's a fascinating thing, especially because the technical requirements of such a long journey, with so many constraints to consider, challenge each of us in a unique way.
Engineers have devised advanced technological solutions so that JUICE can operate in extreme environments, face Jupiter's high radiation belt, the long distance and harsh temperatures. Its 2.5-meter diameter antenna will send the data JUICE collects back to mission control, although it can take close to an hour to travel to Earth. The European mission JUICE is going to be a real revolution. Its collection of valuable data will be used by scientists for years to come and help unlock some of the greatest mysteries of the universe.
So, Raphael, JUICE is an emblematic European science mission. So what is it about this particular mission that inspires you as a rocket scientist?
Well, dream. And dream has always been a very strong driving force.
Acquisition par la station télémesure de Libreville.
For me, but also for, I think, everybody who works in the space industry. And, if we go on a more personal note...
Not even space industry, the space enthusiasts like us, the people who are watching, it really inspires us also.
The real article I wrote was about Jupiter's icy moon and the preparation of the JUICE mission with a focus on the moon Europa. And you can imagine that I would have never thought back then that I would be here standing at Kourou Spaceport.
Wow.
In the Jupiter room.
Just look at that barbecue motion which it is doing to evenly distribute sun's heat.
I are inspired by such emblematic mission. It really gives us an extra boost each time.
And especially when it comes to a mission aimed at looking for signs of life, that is just something else. It's difficult to actually fathom.
Can you, I mean, yeah, the ambition of JUICE, and it's a very complex mission, by the way.
La propulsion est nominale, le pilotage est calme.
So everything is nominal, but thinking that one probe is going to be around the moons of Jupiter, which are unexplored worlds with oceans of liquid water under the ice
La
surface,
trajectoire est nominale, tous les paramètres bord sont nominaux.
where exobiologists expect to find some forms of life. We don't know, like microbes, maybe shrimps, maybe small fish. Probably not, but let's dream. And especially on the moon of Europa, it's just absolutely incredible.
Indeed, Raphael, hundreds of professionals in Europe are working on this crucial mission. We met some of them earlier, and as we know, it takes a whole family to put such an expedition together. So let's hear from some of the partners of this mission.
Bonjour, je m'appelle Victoire de Maincourt, je suis nationalité française, je viens de Toulouse, je travaille chez Arianespace.
My name is Rossella and I originally come from Italy.
My name is Oliver Troll and I'm a German rocket engineer working for Ariane Group in Bremen.
I'm Italian and I'm a telecommunication engineer.
Je suis espagnol, je viens de la ville de Madrid et ça fait 3 ans que je travaille au Centre spatial guyanais.
Je suis chargée du suivi en temps réel du lanceur et de la mission et de vérifier son bon déroulement afin de rassurer à la fois les personnes qui travaillent sur le lanceur et évidemment le client.
In Kourou, during the launch campaign of JUICE, our goal is to check all the final full functional tests, so all the final checks after the transport of the satellite here in Kourou and before the launch.
I'm responsible for the follow-up of the stage integration up to the launch, the treatment of technical anomalies with an end-to-end view, the technical consistency of all information, and the on-site presence in Kourou during launch campaign.
Je travaille à la sauvegarde vol. Mon rôle le jour J consiste à surveiller la trajectoire du lanceur et les équipements à bord. Et si on constate que la mission cesse d'être nominale, on pourrait être amené à intervenir pour assurer que tout se passe en sécurité pour les viandes et les personnes et ainsi maîtriser les risques.
I take care of the assembly and integration of all the units of the spacecraft, and afterwards to make sure that the test campaign goes as planned and that the spacecraft will perform as expected once in space.
If I want to define team spirit in 3 keywords, I can say the first one is collaboration, the second keyword is coordination, and then the third keyword, which is the most important for me, is to have fun. It helps overcoming difficulties and obstacles. So yeah, for me this is the most important part.
So we are coming up to 22 minutes after liftoff, which means that in just over 5 minutes, JUICE will be separating from the mothership and starting its own life in space. Raphael, can you give us an update on where we're at right now?
So everything is working perfectly.
Acquisition par la station télémesure de Malindi.
So we have the Malindi telemetry station acquisition. So in the past 5 minutes, we went from 190 kilometers to more than 500 kilometers of altitude. So it now has a speed of 9.6 kilometers per second, which is absolutely gigantic. It is almost the speed at which JUICE will be separated into space. During the next 5 minutes, we'll increase altitude even faster. We'll gain an additional 1,000 kilometers in altitude. And by the way, the weight of our structure right now is 14 tons about, only 2% of the initial mass of the Ariane 5 when it was on the ground.
That is just unbelievable, 2%. Ariane 5 typically launches geostationary transfer orbit launches. So here we're sending JUICE obviously much, much farther on an escape orbit. How is this different? How does it differ, for example, from launching a telecom satellite, which are many of the satellites that are launched with Ariane 5?
Well, the energy to provide to the spacecraft by the launcher is higher. It needs to escape the gravitational pull of the Earth. Also for geostationary launches, we usually have a launch window of typically 30 minutes to 1 hour and a half, let's say, during which we can try and launch. And today's mission is sort of a rendezvous mission. And there was no launch window. It was what we call an instant launch. So we had to launch an exact time. So this is why everything has to go smoothly, even the weather before launching. Also, geo-launches to the geostationary orbit usually happen in the evening. Today we launched in the morning, meaning that the team have been working all night during the final countdown. And also, we had to slightly adapt the filling of the tanks of the upper stage with cryogenic propellant, as the launcher was exposed to the sun since early morning, 6 a.m. So the sun heats and increases the pressure of the tanks, so we had to slightly underload it by 120 tons, which is, kilos, sorry.
So how is it this mission in itself
We
different in
are
terms of
coming in
preparation?
close for the
we
cutoff
need to take
and
extra
deployment.
care in terms of cleanliness, because before leaving the Earth, we want to know exactly what kind of biological material JUICE takes with it. In French Guiana, there were several institutes which took samples from JUICE in the various satellite preparation rooms. Of course, most of the microbes will be sterilized in space, watched out by space radiations, but some can survive. Here we see on the image His Majesty the King of Belgium and His Royal Highness Prince Gabriel, who...
And they are here as VIP guests.
And we have a cutoff.
Contributed rather importantly towards preparations for JUICE. So we were talking about, we were looking at the difference in preparation, weren't we?
The second main difference is that, you know, JUICE will perform very precise magnetic field measurements around Ganymede, the moon of Jupiter. And we had to measure many times the magnetic environment of JUICE during the launch campaign on the ground to make sure that in space it will measure only the magnetic environment of Ganymede and not its own magnetic field.
Because it has a very, very strong magnetic field, of course.
Exactly.
Okay, and so in a nutshell, looking at the time, we actually have, I haven't heard it from the DDO, did you?
So right now, we are in the stage where the upper stage is performing slight orientation maneuvers to separate the spacecraft in a very specific direction. It's important to do so on time in a very precise way, as it will really drive the satellite injection accuracy and have an impact on the rest of the spacecraft's lifetime in space. Just to give you an idea, in end of May, JUICE will perform what we call a trajectory correction maneuver. And so the better the injection precision, the less important the maneuver is going to be, meaning that JUICE will be able to save its precious fuel for the rest of the mission.
And Raphael, we are 30 seconds away from separation. What are we going to see exactly? And then we'll stop the commentary and wait for the moment.
We are
Let me remind you that this is 3D animation here, but the teams are receiving signals and information in real time, and it is them who will confirm the separation of JUICE on its liberation orbit. They will provide all necessary information to ESA teams so that they can inquire the spacecraft.
And we have separation, guys.
Let's wait for confirmation from the DDO.
Séparation JUICE confirmée.
And this has been confirmed.
Finally, guys, JUICE is off to the Jupiter, and wow, this is going to go for the still. It's gonna come back to Earth for 4 times, but still, it's gonna go to the Jupiter now, guys. Wow.
And it is so.
Congratulations, Arianespace. Congratulations, ESA, NASA, JAXA, ESA.
This is the very, very first.
And let's hope it is successful and we get to see the life inside one of those icy moons.
So special. It's like a reboost each time we launch a satellite. And what a satellite right now. Honestly, I can only wish good luck to JUICE and all the teams for this incredible journey tour.
You can see the
to
relief
the outer
in
solar
their face.
system. That's
In their
absolutely
faces.
amazing what we
Wow.
are living right now.
The atmosphere here in Jupiter is effervescent. There is a true sense of joy and happiness. But as I was saying, of course, this is the very beginning of the journey, and we will be letting, of course, the teams in Darmstadt take over shortly, because they are the ones who are going to be confirming acquisition of signals, first signs of life, from our passenger. You were going to say, Raphael?
No, I was saying to say, yeah, this is the beginning of the journey for JUICE. For the launcher, we may perform what we call a passivation of the upper stage, meaning that the remaining propellant of the tanks is expelled in order to prevent any risk of explosion in space. This is a requirement for a sustainable use of space. And we also perform a very small disposal maneuver in order to remove the upper stage from any operational orbit, giving an extra push of 13 meters per second. And so, yes, and then this is going to be the real end of the mission for the launcher. But right now, let's focus on the joy on people's face. This is absolutely incredible. JUICE is on its way to Jupiter.
And it is especially a joy when you know, considering the stress that a delay brings. Even though we know that the passenger is safe, it is a lot of work for many people to have to delay, and a very safe choice to make, of course, as we can see today.
So again, in a few minutes, ESA teams will acquire the satellites.
We're now waiting for, of course, for comments from Stéphane Israël, who's just been mic'd up in the fishbowl, and he'll be with us very shortly. So we'll of course tell you when he's with us. We'll let you know, and we'll let you enjoy the smiles and happiness on everyone's face.
Mac, but that is not so much true. Americans, I would totally agree that they have very high. Okay, let's just listen him first.
A few seconds delay, but he's with us. Over to you, Stéphane.
So today's mission is a full success. Team Europe has perfectly delivered. I really want to pay our tribute to all the teams who have made this success possible. Arianespace and Ariane Group team for sure, all the supply chain, ESA, our customer, and Airbus Defence and Space, who is the JUICE manufacturer. It's really the success of Team Europe today, with the support as well for sure of CNES here on the spaceport, and with the design authority of Ariane 5. It is absolutely perfect launch today, and it is now the start of a journey for JUICE, 8 years journey.
Cool.
Thank you very much, Stéphane Israël, Arianespace CEO. So we are.
So yes, I was saying America has some. They take more precautions than other space agencies, but they also launch in the cloud cover. I have seen that, but yeah, they have certain limitations, you can say.
Thank you very much, Lisa. So welcome back to everyone. We are standing in the heart of the European Space Operations Centre, ESOC, a facility in Darmstadt, and this is the mission control room right behind me, the main one. We've got a couple of major milestone events coming up. In less than 5 minutes, we hope to get the first acquisition of signal. That's where we actually talk to the spacecraft itself, and that gets picked up by an ESA ground station. There'll be an icon on the screen that signifies that, and that's a huge satellite satellite dish. And in about an hour, we should then have the final and next key milestone, which is the deployment of JUICE's enormous solar panels. So I'm going to be talking to loads of mission scientists and engineers on this mission. And if you're watching and have questions, then you can ask them. You can go on social media and go to #AskESA.
Okay, guys, I think that should be it for this stream. I have some work to do, so I need to go. So thank you so much for tuning in, guys. And that was a complete success. The Ariane 5 has delivered once again. James Webb Telescope, now the JUICE mission. Wow, we will just listen in to more Ariane 5 launches. I hope that happens, but that is not gonna happen. Ariane 6 is gonna replace Ariane 5 very soon. So yeah, thank you so much for tuning in, and I am hopeful we gonna see another launch tomorrow for the transporter mission from the Falcon 9. So I think I'll be able to stream that, so do join in for that. And yes, guys, Starship mission is coming up on 17th of April. Starship is gonna launch. Integrated flight test is gonna happen very soon. Who all are excited for that? And then obviously Falcon Heavy launch is coming up. So this month is a very exciting month for space launches. So tune in for all those things, and I'm hopeful that you will not be bored. So thank you so much for tuning in. This is Pianshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye-bye.